live, and it took like 10 seconds for my stream counter to start ticking, because it was at 0:00:00, and I'm thinking, what the hell? It's not going live, what the hell, you know. Anyway, it suddenly kicked in, and I don't know, the internet's really bad at the moment, so I'm going to be quick. So I'm doing tests with the new segment which I just printed, and had to stick some magnets in the middle shielding area, because that's normally where I put steel, but because the arrangement of the new magnets doesn't work so well, and I kind of had a feeling it might, but I wanted to show the basically I'll use the bigger magnet to try and pull this around. So if we use I've got the right one, that's pushing, I've got it wrong way around. So that pulls in there. This is, I best turn it on this way, because it tends to clog a bit on this steel over here, these motors that are in there. But a bit, yeah, that's better. So yeah, I honestly don't believe that this is going to work, because even if you get the fields right, you need a switching mechanism, really. I don't know, these magnet motors, even the professional ones, they make a lot of noise, and the reason they make a lot of noise, the ones that actually do work, is because they've got some kind of attenuator that moves the magnet up and down somewhere. And so yeah, at the moment so that's pulling there, pushes there, right, but it gets cogged, it cogs right there, right. So at that point it cogs, right. So that's these magnets here, I need to rotate them so they're more like the other ones on this side, because if you come over here it just pushes through, but it gets stuck on that point there. So if we come around to the end, come around to the end, if I get to the end without it will push at that point there. Now let's look at the field. Let's just get my magnetometer on here so we can see what the field is doing. Right, so right, we have I'll just try and get over the top of it. So I am using some very weak, the larger magnets, but the very weak ones. And it's dead pretty much there. And all the way around here. And then we get the dead zones pretty much all the way around here until we get to this. Hang on, my finger's getting tired. When we get to this point, I'll have to move it a bit. Hang on. So we get a field coming out of this end. So we have a field here. It's not as strong as the other one, because these magnets are not N52s. I think they're N42s maybe, or maybe weaker than that. I think there's a lower grade. So you can see the field is pretty weak on this, even though these are 20mm long magnets. So yeah, I wanted to show you that, because yeah, I honestly don't want to waste too much time on these segments, because my anti-drag motor, which I'm working on over there, which is giving me much more hope, because it's a switched field, because when the when these coils are energized, they exert an equal opposite reaction on the segments, on the rotor assembly, which negates a lot of the drag on the system, and that is more promising to me at the moment. If you haven't seen the segments, you'll have to scroll back. Well, you have to look on the earlier videos I did where I was showing you when I was modelling the segments on there. But the segments are very similar to this. Now, the reason I started working on this is because I am looking at incorporating a similar design to this into my anti-drag generator, which is that thing, right? So if we can get it so that we have good lot of thrust forward on these arrangements, these segments, then I could incorporate something very similar in my anti-drag. Let me just take my charger lead out a minute, because I've got a whole bin full of these things, right? So let me just show you what I mean. I've been working on this for some time now. Let me just put this light on. And I keep running out of plastic. So look at all this lot in here. This is all the research I've been doing with all these anti-drag assemblies. So I mean, it's getting ridiculous now. I mean, these are a bunch more down here. That's what I was doing. So anyone that hasn't looked at my previous video, there's the latest segments, which I've just scrapped, which I'll yeah. So I've got them in sets of 6 basically. So we've got loads and loads and loads of these things, and it's costing me an arm and a leg. And there's another segment I did. So yeah, this was the one where the main drive magnets that produce the power are actually set a long way back, and the new ones that are on the actual anti-drag generator, these magnets at the back here, I moved them right the way forward, which works a lot better. So I wanted to just show you that. Yeah, my bin's getting pretty full of plastic. I'm going to have to recycle all this at some point. I'll either make glue out of it or find somebody that will take it off my hands and make it back into 3D printer filament. So this thing hardly has any drag on it. I'll be doing some more tests on this in probably a week or 2. At the moment I am just experimenting with this, because if we can use something like this to increase the forward rotation being to accelerate the rotor instead of it slowing down when we put a load on it, then that's great. So this is part of the reason why I'm doing these experiments. But if it can work in a magnet motor, great. That's even better, obviously. So it's kind of a link between magnet motors and anti-drag motors, because basically the same principle. I'm using the same principle of these arrays, these magnet arrays, in my anti-drag generator. So that's why it's valid for me to experiment with this idea. But these actual magnets that are in here at this end between the last 3, 1, 2, 3, these need to be tilted outwards like that. They need to be tilted instead of in that orientation. They have to be tilted that way in order for me to get through there, because at the moment it just sticks. Here's a weaker magnet here. So at the moment it just cogs right to that point there, and that's because the field on the side of these magnets, more of it's pulling than it is pushing, so it's going to pull in instead of push out. So by adjusting the orientation of the magnets, what you're adding on a bubble of field, the opposite field, and that bubble pushes it along to the next one, and if you haven't got the orientation just right, then it will cog and get stuck, and that's what's happening basically. Anyway, so yeah, I like this bigger one for experimentation. Obviously I can put much bigger magnets. There was no point because these magnets are wrong, so I'm going to have to 3D print a new one. I did put my steel pins in there, so I used some 3mm wide welding rod, which I cut off, and I pushed in, so I've got 2 pins in there. If I take 1 pin out, the cogging gets worse, so they definitely help, and because they help to short the field out between the transitional point where the 2 fields change. So when we've got a traction on this side, over here it's actually pushing over here, but so this field is shorted out through that pin there, and it helps to collapse the field so that we don't have a cogging issue at the beginning. But we have a cogging issue right here, so obviously that's wrong. So I had a feeling it might be, but yeah, I wanted to try it, and I put some biasing magnets in here. These magnets are stuck in here. I tried to offset the cogging problem. I just put some extra, instead of it pulling in, I was trying to push the stator magnet, or the magnets on the outside. I was trying to push it away with these little magnets are stuck in there, but to no avail. Doesn't work, so we're gonna have to readjust these, unfortunately. But anyway, it was interesting, and yeah, so that's it really for now. I just wanted to give you a heads up on where we're at with this, and obviously every experiment you do, you learn something new, you figure something out, but ultimately one of my main feelings with magnet motors is that no matter what you do, unless you have some kind of a switching mechanism going on, some kind of mechanical switching going on, you always end up with a situation of balance. When I say balance, I mean the input, the attraction point, it's always going to be equal to the amount of drag that you get on the assembly, so that even if it pulls in, you think you're going to get thrust, but overall over the distance it's going to slow it down to the point where you lose all of that attraction acceleration. So what happens basically, even if you can get past that, if you have some kind of switching mechanism which basically switches the field off when you get to a certain point, and then you engage the push to push it out the other side, even then you lose so much in friction and other things that are going on. The field generally is in a circle. So what I mean is you get this, the field is wrapping around here even though you can't see it. So even though this front side is screened, right, even though it looks shielded and everything, you've still got a field coming all the way around here. You know, the field is coming out this side and it's looping all the way back. You just can't see it. It's there, but my little magnetometer thing, this thing, it just can't see that because it's a shorted field. It's a field that's so weak, but over a large distance it has a, so it's going to slow you down. So you might not be able to see it. Even my viewing film can't see it. It's so weak, but it's there. So over a larger distance, you might think, oh, I've got acceleration, but on every rotation, that amount of drag is going to be the sum total of it slowing down. It's going to drag it down. So the only way around that is to have total 100% effective shielding, but you can't get that because if you introduce the steel, that introduces drag, so that's going to slow you down. So no matter what you try to do, there's always something that gets in the way, and that's what we're all fighting against. We're all trying to overcome that problem, and 99% of the time you just can't envisage what's really going on, because magnetism is interactive. I mean, when I say interactive, for every field that you introduce, it will react with the field adjacent to it. So you have a cascading effect around the magnet arrays. If you introduce another magnet, it distorts the field and it affects all of the other previous magnets. They're all working together either for you or against you, and that's the problem. It's such a nightmare, it really is. It's hard work. We can't see it. It's a shame we can't see magnetism, but we can. If you could get a camera, it would be so cool if you just had a camera, like an infrared camera, that you could literally see the magnetic fields, but we don't have that, and that's where we fall flat on our face basically, because viewing film is not very effective. You need quite a strong feel to it to change its actual translucency, the translucent effect. It needs quite a strong field to change that, and we've got something like a 60% resistance of it changing, something like that. It's a guess. It's not an actual figure, but I'm just guessing. It's something like 60% of not responding to the field until you get really close to the magnets themselves. So this is where we're at, really. Anyway, yeah, I'm going to go back into 3D SketchUp model. I'm running out of plastic though. I mean, my filament is, yeah, there's not a lot left there. And I want to print more segments for the anti-drag motor. I've got another 6 of them to print, so I'm really reluctant to print more of these at the moment, because I've got to go and buy another another kilogram of 3D printed plastic, and what with the energy crisis right now, I don't know where we're going to be in 6 months. Everything's getting so expensive now. So anyway, thank you. We'll see you later, alligator. I hope I'm not